Welcome back. Okay, now that we have reviewed all of the different kinds of translations for our quadratic functions, let's go see about putting things to work. First off, this has a small typo in the equation. Let's fix it. It's supposed to read y equals -4 parentheses x plus 2 squared minus 3. That's what happened. All right. So this is in Vertex form, and Vertex form is very user-friendly to find lots of information very quickly. So the first thing we can find, as we are asked to do anyways, is the vertex. The vertex from a vertex form is completely visible. If y equals a times x minus h squared plus k, my vertex form, the vertex is the h and the k. Whoops, sorry. All right, so the vertex is h comma k. And remember, you're going to change the sign on h. Whatever is inside of parentheses, you do the opposite of it. So the vertex, since this is plus 2, the opposite of that is a minus 2. And then k, it is what it is. That was easy. There's your vertex. The next thing we are asked for is the axis of symmetry. The axis of symmetry, remember, it is an equation of x equals what? The number in the x position of your vertex. -2. Done. Love that. I love things that are easy, that make sense, that come together so quickly. So if you need to make a note for yourself, we can. Same number, not a hashtag, a number. Same number as x from vertex. Okay. So now let's get ourselves a couple more pieces of information before we graph. This negative, let's talk about a. A equals -4. That negative tells us that we are going to reflect down. It's going to open down across the x-axis. The other thing that we see is the 4. The 4 is definitely greater than 1, which means that we are going to have a narrow vertical stretch. So on your state tests, on your end of course exam, sometimes they're going to have you just go graph it. Other times they're going to have you describe what is going on. How do you know from the equation? So here, before we've even drawn it or seen a picture of it, we've already been able to determine a lot of information about what is happening with our quadratic before I even get to look at it, which is pretty great. This is a beautiful set of questions that your state test will be asking you, guarantee it. So at this point, we can go draw some things before we implement the use of our graphing calculator. So my vertex will be -2, -3. So let's plot that. Let's go left 2 units and down 1, 2, 3 units. There's my vertex. All right. And then my axis of symmetry is x equals -2. So it will go straight through my vertex, and this is the perfect fold in half line. All right. So at this point, I would be breaking out the graphing calculator to go determine what my points are surrounding that vertex. It's just helpful. If we needed to, sure, we could go ahead and work them all out by hand, but you will have this tool to help you on your test, so why not use it now? So remember, we start always on a new document every time, and no, we never save. And we need a graph. And it's not graphing. There we go. All right, so let's type in our function correctly. So let's make sure that you have a -4 and not a -4. This is a -4. The minus will only happen in front of the 3. -4, parentheses, x plus 2, close your parentheses, squared. Remember that squared is right next to the number 4, and then -3. Please make sure that your equation matches what we wrote down, like exactly. Okay, push enter. And there's your graph down here towards the bottom of your screen. And it's small, but that's okay. Let's go look at the table so we can grab some points. Control T. So right now on our table, we see values like -39. No, can't graph that. -19. No, can't graph that. Hey, a -7. That I can graph. So we now get an idea of where we should center our t-table so that I have usable information. Why bother to write it down and try to use it if it's not going to fit? And I know it won't fit. Okay, so let's write down some numbers on your paper real quick so we know what we're doing and how we're getting it. So we saw here that -4 got us a value of -19, not real usable. But -3 gets us a value of -7, totally usable. -2, -3, hey, that's our vertex. We know that point. -1, -7, and then 0, -19. Okay. That gets us great information to help us plot. So using those, let's go plot them on our graph. Sorry, I can't have them both showing at the same time. So let's go left 3 units from our center origin and down 7. 1, 2, 3, 4, 5, 6, 7. I already have the point -2, -3, that's my vertex. And then from our table, -1, -7. So left 1, down 7. And here's our graph. Perfect. Here is my vertex. And this is my axis of symmetry, my AOS. Great. Let's try number 2 right below it. Number 2 is not in vertex form, so we have different information that we can start off with to help us out just in analyzing our graph. So here we remember that we start looking at A, B, and C, because we know we're going to just kind of have to analyze from a different direction. A is the term in front of the coefficient in front of x squared, which is a 1. B is the coefficient in front of the x, which is a negative 2. Make sure you take the negative. And C is your constant term at the end, which is a 1. All right, so let's begin analyzing our function. When you're using standard form, the first thing that we know automatically is the y-intercept is going to be C, the point 0, C. And we know what that is. Y-intercept is going to be 0, 1. So that didn't take any work. That was nice. The next thing we can find is the axis of symmetry, the AOS. And that's negative b over 2a. We practiced that a couple of days ago. So let's plug in those values. Negative 2 divided by 2 times a, which is 1. A negative and a negative side by side. Oh, it's a positive 2. And 2 times 1 is 2. So what's a positive divided by a positive? Oh yeah, that's another positive. What's 2 divided by 2? 1. Which means that the axis of symmetry, remember it's always an equation, is x equals 1. Great. So now let's use that information to go find your vertex. We're going to plug this 1 into our original equation. So f of 1 will be 1 squared minus 2 times 1 plus 1. You can use your handy-dandy calculator to help you work that out. Let's do that. So Control Doc, use our calculator, and let's type it in exactly as we see it. So I've got parentheses 1, close your parentheses, squared, minus 2 times 1. Make sure you use the minus, not the negative. Use your parentheses, plus 1. You should get, a value of 0. Interesting. So that means my vertex is the coordinate point 1, 0. All right, let's go plot this information. Let's go use it. My y-intercept was the point 0, 1. Over nothing, up 1. My axis of symmetry was x equals 1. So here is my dotted line. Straight down x equals 1. And then my vertex is the point 1, 0. We remember that what happens on the left side also happens on the right side. It's the joy of symmetry and parabolas. So 1 unit on the left means that there should be a point exactly 1 unit on the right. And now we go and break out your calculator just to get the rest of our points from our table. So Control Doc, let's add a graph. Let's type in your equation, x squared minus 2x plus 1. There it is. Does yours look like mine? I hope so. Only maybe a little more clear on your calculator. Control T to go get the table. And we see we've got several points here that we can use that are very visible. I can't see a 16 on my graph, but I sure can see a 9. So let's start drawing our t-table onto our paper. X and Y, -2, +9. -1, +4. 0, +1. 1, 0. Let's go down our table in our calculator. +2, +1, +3, +4, and finally +4, +9. Do you have to plot all those points? You should, so that you can see them. And it's not like it's hard. It's just a little bit more to do, but not too much. Let's go plot them. -2 up 9. There it is. -1 up 4. 1, 2, 3, 4. 0, 1, we already have that. It's nice when things match. 1, 0, we have that. Again, things match, that's great. 2, 1, we have that. Oh, it means we're doing right things. We're seeing things that should be behaving and like we expected them to. 3, 4, to the right 3, up 4. And to the right 4, up 9. And there it is, folks. Our new parabola. So again, your state test is going to hand you an equation like this, and it's going to ask you a bunch of information, which you could determine using your graphing calculator, or you could determine just based on the information and rules of behavior of an equation. So please stop the video and go attempt to do number 3 and pick it back up on number 5. All right, we're going to do number 5, and then you're going to do number 4 and number 6 on your own. So here on problem number 5, we're going to graph the vertex. We're going to graph these two functions and see how they are similar, see how they are different, and what are their transformations. So here on number 5, we start with f of x equals x plus 1 squared. Oops. So this will have a horizontal shift to the left, 1 unit. Everything else will be the same as our original parent function. So let's go plot those. Hopefully we know their behavior by now. So I went to the left, 1 unit. I know that the surrounding points of my vertex are always just 1 unit up. And then the second point is always 4 units up. And my third point is always 9 units up. Did you see that pattern of behavior in our previous t-tables? I hope so. So this is f of x. We took the parent function and slid it to the left, 1 unit. Let's look at g of x. Three times x plus 1 squared. So every height from our pink f of x, we're going to multiply times 3. So slide left. Multiply y values or heights by 3. All right, let's do that. So this I can't multiply by 3, it won't show. Here I have a height of 1, 2, 3, 4. 4 times 3 is 12. If this goes to 10, 11, 12. Here I have a height of 1. 1 times 3, 1, 2, 3. Height of 0 is 0. Height of 1 times 3, 3. And again, height of 4 times 3 is 12. 10, 11, 12. This is a horizontal compression. There is my g of x. A little bit weird, but not too bad. We just saw what the behaviors were and how it changed. So if you'll try number 4 and number 6 and come talk to me if you're stuck, I will be very happy to help you out. Oh, and we can always say what our vertex was. So we have a vertex of -1, 0. Whoops. And we still have a vertex of -1, 0. And we'll write on here, this has a horizontal compression. It actually has a factor of 1/3. Is the inverse of that number A that was inside the parentheses. All right, if you get stuck, come and talk to me. I'll be very happy to help you.